Hi, my name is Andrea Estrada, and this is my project Maze Crawler. Maze Crawler is a Pacman-esque game with an added multiplayer twist. I created Maze Crawler using Python 3 and its sockets and Pygame modules. Two notable parts of my game are its full graphics and comprehensive audio. In this demo, you will get to see all the graphics, but won't be able to hear the sound effects. Note that these sound effects include background music and noises when certain events are triggered. There is also the option to mute all audio. Among the key features of my game are 5 adaptable maze-generating algorithms that can be adjusted to accommodate any size specifications. These maze-generating algorithms include recursive division, binary, hunt and kill, sidewinder, and Ehlers. As players go through each level in the game, they play on a maze generated by a different algorithm. This gives a unique look to each level and makes the user experience more interesting. Furthermore, to make gameplay even smoother, I have algorithms to randomly generate loops in the maze. This eliminates any dead ends that would give players unfair disadvantages if cornered. Another key feature of my game is the interactive UI. Since Pygame does not have a built-in cursor function, I handcrafted my own. The ability to enter information allows for a more personalized user experience. For instance, one key function involved with user input is the user's ability to create their own game code as they play. To initialize a game, players choose their own 5-digit number. My backend then uses that player-selected game code to start a new server from within the client. To enable the client to start the server from within a GUI, I utilized a subprocess on file input and output. This is a distinguishing feature of my game. Typically, sockets-driven games require that players go through a command line to fully start up the server before even running the client files. My user input also includes data validation feedback to the user. If initial entered values are invalid, they show up as red. Furthermore, if a player attempts to join using an inactive game code, my game will remember that code as invalid for future use. My game also has a couple of different types of AI. One AI is my ammunition. It can be clumsy to point and aim using keys or a mouse. So, I coded artificially intelligent ammunition that auto-detects targets by smart aiming at the opponent. Instead of having to steer ammo while also navigating the game board, players simply have to press the spacebar on their keyboard, and their ammo will go in the correct direction. Two larger pieces of AI are my 3 different AI monsters. In level 2 of gameplay, AI monsters choose random paths as they navigate the maze on their own. AI monsters in levels 3 through 5 track players using 2 different pathfinding algorithms. Since my game boards have multiple paths to get to one location, I couldn't efficiently use backtracking to get the monsters to the players. So, my players are directed by Dijkstra's algorithm in level 3 and the A-star algorithm in levels 4 and 5. So what I just covered in depth were the key components of my game, but there are also other fun features including player stats, randomly generated point piles, and several different types of cool power-ups. I'll leave it up to you to play Maze Crawler to learn more about those. Thanks for watching!